put this on?
Something different?
I don't have your audio.
You don't have my audio. Oh, I see. You don't have the mic that I'm talking into. Got it. Yeah. Yes, I broke the mic. No, I didn't break the mic. I took the clip off the mic. Just trying to. Okay, it's like that. So, is that all right? Okay, he's got reasonable sound. Good. All right. Voice protocols aren't stable. We're still coming out with new products very fast, which means people will tend to implement mistakes. Vendors will take shortcuts. People will try to get to market without bothering to do things cleanly because they're trying to, everybody wants to come out with their version of a white phone that also plays music because Steve Jobs said he might do that. So you get that kind of, race to market kind of thing. And yet, it's telephones. So it's already legacy stuff. Gear that, the current generation of Cisco phones were built in the late 90s. And they think that's perfectly reasonable because in the phone world, people take 10 years to deploy a new phone system. So whereas, you walk into a shop and found them running Windows 98, we'd all go, ooh, ick. The vendor doesn't even want you doing that. And yet you can find Windows 98 vintage telephones around with that level of technology and security capability and all that kind of stuff. New products that keep coming out are coming out vulnerable. People are doing silly things. You hear stories about voice phones being shipped with the debugging turned on, so if you bothered to rebuild the GNU debugger GDB, you could hook up to the phone through the debug port. Silly things like that. So new products are still coming out vulnerable. This is not like it's a solved problem. And I got to make up a buzzword when I was doing the slides here. So, it used to be that, the cool hot thing was to attack something that was very popular like Windows XP. And as they get these things more and more stable, it's not the cool target these days. So you got, like the cause célèbre. So I think that target célébré is a new term, which is, the hot target next week is going to be something else because we're not going to have XP to beat up anymore. And of course, Vista is all much more secure, right? So that's going to be boring. So we have to. Anyway, there are new targets coming out, and what's a popular target is something you have to think about. The other reason to think about it is customers think they're buying secure products. Cisco is an example of this. Just because they put up billboards in Northern California that says they sell secure networks doesn't mean they sell secure networks. If you pay for an expensive billboard and pay a lawyer to sue some guy who tries to do a talk at Black Hat, and then you ship VPN concentrators that use FTP and clear text passwords to update the configuration files, then you've got a what do you say versus what do you do kind of a thing going on here. And the customers assume they're buying something secure. Nobody ever got fired for buying a Cisco network, right? That kind of thing. Pointing out these issues, in theory, will make things more secure going forward. So this is, one of those, we're trying to make people's networks more safe, and I'm not trying to break things. I'm not trying to help the bad guys, destroy the world or anything like that. All right, architecture. This is basic stuff. How many of you are, and with the lights off, I can't actually, how can I ask questions? How would Major have done this and win his contest? I can't, if I ask questions and you raise your hands, I'm not going to see them because I can't see any of you. Anyway, let's try this anyway. How many of you are managing a voice over IP network now? There's a few brave souls. How many of you are involved in the evaluation or purchase or deployment or somewhere at that phase? Anybody going through that? One. You're having a good time? Two. Oh, over here, some more. How many of you are actively attacking voice networks? Yeah, see? Good. Yeah, fish, barrel, point, shoot, reload. Yeah, it's really boring. Yes. So anyway, okay, so a little just going through these. Remember, when I'm talking about components, I'm thinking like a bad guy at this point, so I'm thinking about targets. One man's product feature set is another man's target list. So these things are what used to be private branch exchanges, which means they're fully featured phone systems. And if you talk to an enterprise environment, they expect the phones to have all sorts of doodads and gimcracks on them. You're supposed to be able to get music on hold and follow me services and conferencing and all sorts of cool features. They tend to have a call manager. That's a Cisco product name, but that's sort of the generic term. There's this widget in the middle which is doing call processing. In other words, there's a target in the middle to go after. There's things that are doing proxying because some of the protocols were not designed to be NAT friendly, so you have to have proxy capabilities. So there's stuff like SIP proxies around doing that, SIP being session initiation protocol. There are gateways. There's the old-fashioned plain old telephone system, or POTS. So there's gateways between the voice systems and the POTS system, and gateways between multiple voice systems. So again, you've got things at the edge, and they're run by the phone department, and one would like to think these things were safe. They apparently are not trusted, because when I go start to do talks on or classes on this, and people you say, what kind of hacks do you expect to see? And they all assume some bad guy is going to be sitting in a coffee shop in Beirut and connect into their voice network and read the CEO's email because the voice to POTS gateway was stupid or something like that. So the people assume this is an issue. Then there's all the back-end fancy stuff. You've got directory servers. So this is really cool. If you work for an 80,000-person organization, you can pull up people's names and identify their phone number, and you can do it through the phone. That's all very cool. That also means that the right kind of bot can crawl through and get your entire phone directory. And then what do you keep in your phone directory? If you're lucky, it's just names. If it's got titles and things like that, you get targeting information. If I can find all your execs that travel and have fancy things in their laptops, or I can find all the developers who, how many of you are developers for big corporations that have the source code of your product sitting on your laptop that you have with you? You don't want to admit that, do you? You kept that laptop up in your room and you got your second laptop down here. You did do it that way, right? And you run encrypted disks. You should be doing this. People can do targeting. You got to think that way. You got to think like they're going to be bad guys out there. And then there's voicemail servers. How many times I saw this about 2 weeks ago, so I keep collecting examples. I'm having a conversation with the person who runs somebody's BlackBerry Exchange server, the BES server for all their crackberries for the executives. And she proceeds to check her voicemail with me talking to her, and she picks up her phone and goes bash, 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 bash on the 3 button. And there's surfing over somebody else's shoulder to pick up their password by looking at their keyboard. If you're really good, you can run exploits to do this with SSH by catching keystrokes and the timing. But you don't have to do any of that if they have a 4-character password and they're all the same digit, and they will do this with people watching. So voicemail is a really great place to find weak passwords. And of course, nobody in businesses or other kinds of environments would ever leave private messages on voicemail. Think about that. So anyway, that's another target. Once you can get the phone system and all the data attack models together, it gets kind of interesting, of course. Then you got all the infrastructure stuff behind it, which the phone people don't think about and the network people may not think about. So you get the standard things that you do in a directory, an infrastructure environment. But if you think about them like targets about the phone system, they're more interesting targets and interesting in different ways. So you got like directory servers, like if these things are tied to Active Directory or something. DHCP, DNS, all these kinds of servers, because the phones are dumb. The typical voice over IP phone, if it's an actual dedicated instrument, is stupid and it's picking up all sorts of information from the infrastructure. Hopefully there's log servers, although phones are even worse than computers in general about having instrumentation. And then there's all the routers and switches and stuff. If sort of in a perfect world, the phones would be like the voice over IP telephones, and things doing that would just be standard network devices, and so that wouldn't be an interesting comment. But you get various vendors like Nortel and Cisco where there are special things in switches to know about handling phones, and there's special things in the routers, and so somehow we've managed to get voice-specific components. And so now you find products that are voice over IP ready. It's sort of like, I'm trying to keep track. I haven't found one yet. I'm waiting for a voice over IP ready power strip. Nice, dumb, stupid power strip. And say, because they used to find SNMP manageable power strips, even if they had no computer in them, or Windows compatible power strips. I mean, you would see these strange things that would be compatible because they were special products. All right. So I've got, that's interesting. All right, you can't see the edge of the slide. You're not going to miss too much. Anyway, this is a diagram I ripped off from another presentation, and apparently there's copy protection in the diagram. No, actually, the pictures are sufficiently exotic. Those black clouds were just clouds that said switch network in them, so there's nothing big there. Classic voice network kind of thing. I've got phones up here tied into switches that know they have phones on them, going to some switch fabric. And then there's servers and desktops and things tied into some network, and that's tied into some other switch fabric, and they're all plugged together. And there's various and sundry infrastructure stuff in the middle. That was what was in this box. So now I've got my phones and my computers tied together. So the phones are a good path to attack the computers, and the computers are a good path to attack the phones. And apparently the voice vendors don't actually draw pictures like this and go, ooh, gee, I can attack all those things from the other places. So this isn't a network diagram. This is a targeting map. You got to think about it that way. Now, protocol elements. So phones, voice phones, VoIP phones, are doing a bunch of voice protocols. This is this stuff over here. And then they're doing all the extra bits to make things work. And this is one of the places that the vendors will get things wrong or be sloppy. And therefore, there's places you can have exploits happening. So you get the usual suspects for protocols for something that's trying to run as a simple, dumb appliance. The main one that's kind of interesting here is they'll tend to have an HTTP server in them, a web server in the phone, so you can configure it. This means I have a web server, which means, go back through your copies of the archives of every web server attack talk given in the last 10 years and try that on the phone, because it's a little stupid device, and that might be worth doing. Then the lower level stuff, it's all the usual kinds of protocols with a few extra sort of modern fancy features. I actually forgot the typo on this slide. That's cool. So it's UDP, not UPD, of course. So you got TCP and UDP, and they might be running TLS if they're doing encryption, and that's running on top of IP. And these are all boring protocol components, right? I mean, we've been building TCP implementations for, 15 years now, something like that. Same with IP, some of these things. And yet phones can get these things wrong these days because they're new products and they go through new development cycles. And then they're adding in fancy extra features like quality of service, so they can do control of how much bandwidth you get, or VLAN tags, or power over Ethernet, or 802.1x, or some of these other extra features, because they're trying to sell hot new products. And every time you add another protocol in, it's another chance for the vendor to screw it up, and for them to ship the product with bad defaults, and for the people who deploy it to configure it insecurely, or not knowingly, or unknowingly configure it insecurely. So all these things are, every time they add another feature to these kind of things, it adds another possibility for how you can attack it. And you could call it the attack surface, but there's actually a technical study area called attack surface analysis, which requires looking at code and stuff like that. And all I'm saying is every time they add a new protocol buzzword on the marketing slick, you can tell that the product just got a little dumber. All right. Things that have happened in the past. If we're trying to do exploits in the future, it's useful to look at what's gone on in the past. Most environments, like the computer stuff we've done, we expect bugs in the past to have been fixed, and we assume that if something gets talked about by CERT and on CNN and in the media and Microsoft publishes patches against it and blah, 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 that this would make things visible enough that other vendors would figure out to worry about this. So like ping of death. Ping of death started happening in the late 90s, and you'd think that anybody who built a test plan for an IP protocol stack since then would have said, oh, well, we make sure we have a test for ping of death in there, because we wouldn't want to do that. But these things keep coming up, stuff like that. In the voice world, there's the standards-based stuff, so you've got SIP and RTP and all the IETF protocols. And unfortunately, because voice systems last a long time, vendors have this penchant for doing proprietary protocols, and they'll get away with it because it's a closed environment. In the old days, you bought 7,000 phones from Nortel, and you bought all the Nortel widgets to plug into your phones, and it all was just a closed system, so nobody cared about the protocols. So the net result of that is you get some old things floating around, crufty old protocols that didn't work well when they were brand new, and yet get used today. So like in the CCITT standard space, that was the X25 and all that stuff that was around before the internet, the stuff that was popular in the 80s. They had a protocol called H323, which was for video conferencing, and it had a call setup protocol called H228. Now, in case you hadn't noticed, we're all using TCP/IP on the internet these days, and part of the reason is because the CCITT protocols were terribly complicated, hard to implement, hard to make them interoperate, and had all sorts of encoding formats that were too complicated, and it was just a pain in the neck to get it running. But the phone vendors didn't notice this because they were building things in their own closed little world. And you then get things like attacks against the ASN1 DER encoding format, which is something that happened in the SNMP world, and it's happened in the certificate world. And then a bunch of grad students in Finland bothered to write a Java program that fuzzed H228, and they suddenly can start finding bugs like this in phones. This is an example of something that happened. And this is the classical cycle of Avaya shipped phones. They thought they tested them. I'm not sure how much they did. I assume they tested for something. They certainly didn't test for edge cases. They assumed nobody would ever send, they assumed they were in a benign network, apparently, and nobody would ever send bad things to them. So anyway, they found a bunch of bugs in that. That's an example of this sort of thing. You pick an old protocol, they think it's okay to run with it, and then some kid comes along and bothers to write a fuzzer in Java in 5 minutes and becomes famous. Support protocols. They're phones, therefore, think small, stupid computer with low budget. think other negative thoughts if you want. People have attacked web servers. People have attacked the LDAP interfaces inside the phones and inside the directories. People have attacked the DNS in the phones, the DHCP capabilities. So they would tend to put these generic protocols in. A Cisco phone having a badly implemented DHCP client. So it's like, I don't think Cisco actually invented DHCP, but I think they had people around when it was invented, so you'd think they'd get this right. That's a naive way to look at it. But in reality, what happens is, they acquired some startup in the last 5 years, which, paid some bunch of 55 programmers in India to implement something really, really fast that they'd never implemented before. And so you basically get fresh, raw implementations of things, even out of big, big companies. So you can get vulnerabilities in the most boring places. On the server side, you get the equivalent kinds of things. People are doing call management with this box in the middle, the call manager. And so you have to send it control messages. He's got more lights he's putting on. Anyway. Well, I just see more, because I can't see the clock. I can't see my keyboard anyway, because it's designed to record, I know. So the call manager in the middle is accepting messages from the phones. And they, again, think it's a benign environment. So little things like there's a message that gets sent when you pick up the phone and pick up the handset and the phone goes off hook. Well, what happens if you get 10,000 of those a second hitting the call manager? They don't think things like this. And it's like a one-packet UDP message in some cases. So it would be simple to do that. And again, it's a server in the middle, so all the usual kind of server attacks like LDAP and DNS and DHCP and stuff like that. You end up with some protocols which are new enough that other people haven't bothered to attack them, and they might be looked at if you're trying to take out the phones. Like if you can screw up the quality of service processing, you can make it so the bandwidth management for the phones is bad, and then you got the phone audio quality can be reduced. So in the voice world, you can do denial of service attacks much easier because people are listening to the signal. And if you screw up the timing on somebody's TCP connection and it has to do packet retry underneath your browser, you're not going to see that as the human unless you're one of us and you run Wireshark at the same time as your browser. Some of us do that, right? Normal people wouldn't, mundanes would not do that. But they'll notice the phone quality go glitchy if you've got the audio stream getting screwed up because you've got the quality service messed up. So you get some of these newer protocols. You can get cases where it's a place to go off and bother to attack that. I don't know. I don't think there's any fuzzers against QoS values, at the moment. But that's the kind of thing somebody would go off and build. Then there's the infrastructure bits. Remember, I drew all the switches and extra networks there. The Cisco example. Cisco's done a lot of these things early in terms of voice over IP, and so because they've done a lot of good stuff, there's a bunch of examples of little mistakes they've made here and there. So they have this thing called CDP, which is Cisco Discovery Protocol. So mistake number one, they have a proprietary protocol. They didn't do a standards-based one, which is cool and hip, and that's the way Cisco does things. But that means that Cisco invented it, and only people who drink the Cisco Purple Kool-Aid were reviewing it, and they don't sit around thinking about trying to attack it, apparently. So you'll get stunts like, they did the Cisco Discovery Protocol message that comes out of a phone that says, "Hi, I'm a Cisco phone." And when you turn on network access control, speaking of endpoint security here, if you turn on network access control on your Cisco switches, under some conditions, if a phone sends a CDP message and says, "Hi, I'm a phone," it says, "Oh, well, I'll let you on the network anyway because you're not a Windows box, so I can't ask you to run all that network access control software. So we just have to let you in." Now, this is a low-level Ethernet message, no authentication, no signatures, no requirements that you can tell exactly what port it came in on, none of the kind of limitations we've learned in the last 20 years to do with real protocols. And so, I can generate a CDP packet that says, "Hi, I'm a phone." And everybody can do that. You just do a Wireshark trace and take the packet, replay it. It's like not hard. So you get this kind of a thing where the proprietary protocol, which was trying to wedge some features in past the protocol stack, can end up causing flaws. There are network access control based issues other than CDP. There was a report about a week ago. Some kid in some high school got expelled because they turned on NAC at his high school, and apparently if you report back to the NAC software that your operating system is the null string, it assumes you're a phone or something like that, and it just lets you on the network. And this kid found this disgusting flaw in their protocol and exploited it, and so he got expelled. which, it's a kid. Maybe he shouldn't have been jacking the school's computers. You can have that whole philosophy, good boy, bad boy debate. But the vendor shipped something that was configured this way, and they put it in a high school. So that says the requirements were screwed up. It says the implementation was screwed up. It says the deployment was screwed up. It says whoever did the security review, it's like we're putting it in a high school, so there's high school kids out there. Hasn't everybody bought a copy of Hackers? When you freeze frame it at the point where Angelina Jolie looks the cutest, the whole thing. It's like, what, high school kids haven't heard of Hackers? Hello? Let's see, we've got to do an age check now. So anybody here who's in high school? No, they're hiding? No, okay, fine. Well, it's a weekend. You never can tell what kind of scruffy characters show up at these conferences. Anyway, infrastructure protocols, IP layer things. We've been finding, you do goofy little things just because you're trying to get warmed up to do some work. So it turns out if you send different link ping messages to Cisco phones, you can sense what model phone it is. Now, if they can get that kind of protocol implementation wrong, and it's Cisco, they're presumably better than some random vendor in Taiwan who's making clone phones. So if they can get it wrong, other people are going to get it wrong. And IP is an example of something. They screwed up the ping time, the ping message format. And these things are written down and have been for 20 years. It's not like this is an exotic new protocol. It's hard to do. ARP things, once I've got phones hooked up to switches, now the switches are part of the critical infrastructure for my phones. And it's even better to freak people out by dropping all the phones in a building than dropping all the computers, because it scares more people. And so things like ARP storms, screwing around with ARP tables and switches, trying to make the thing and think that the same phone is on 7 different ports plugged in. All that kind of icky things you used to do to attack switches. Back in 2000 when Mudge was giving switch attack talks at Black Hat, all that old crufty stuff, try it, because it might still work. Because the phone system thinks it's a closed system even though it's not. And they assume nobody would ever know the protocols running inside the boxes. All right. Vendor behavior. Again, this is back into bashing here. And I use specific vendor names, but the point is you end up watching people do these patterns, and you end up wanting... It's a good thing to think about this because you can see where they're going and where they're not spending their energy, and so you can use that to identify possible areas to attack things. All right, so let me tell you who I'm talking about for vendors, just to get calibrated here. You got the people who used to make telephone hardware, like Avaya and Nortel, companies that used to make telephone gear sort of pre-AT&T breakup the first time, that kind of stuff. And they have started doing networking stuff also in various ways. Avaya, can't figure out how to spell switch, and so they do deals with Extreme or various other people. You get people like Nortel who bought Bay Network, so they actually have all the gear themselves if they want to run it that way. And you get other combinations. Then you get the network hardware vendors like Cisco and 3Com, where Cisco grew into doing the phone stuff from the networking side, and 3Com, I don't know, well, there's a tipping point person in the room, so I better not say anything too snarky about 3Com. But it kind of looks like they kind of slinked out of town, stopped building routers and switches and terminal servers and Ethernet cards, and started declaring themselves a phone company that had an IDS subdivision. As near as I can tell, that's what they did. I've said this in front of the 3Com engineering VP, and he actually didn't stop me. But anyway, 3Com used to be a network hardware vendor, and now they're doing phones, so that's why I put this in the category. 3Com has no excuse for getting any protocol wrong in any phone they ever ship ever, since they were around when the Ethernet standard was written. So no excuses, none. Anyway, then you got the network operators who are also doing goofy things. So you got Singular and Verizon and Orange and whoever else is out there, and they again think they're in a closed environment and they can just control the entire thing, and that gives a really bad security attitude if they have any security clue at all. Then you get the instrument vendors. Voice phones are cool, so voice over IP phones are cool. So you're going to have you're going to have iPhones from 3Com. No, that's not one of the iPhone vendors. You're from Cisco or Apple, and then you're going to have you go to CeBIT or some show like that, and there'll be 55,000 Taiwanese vendors of voice phones, with a big sign that says we're secure. We do 40-bit WEP on our wireless phones, or like stuff like that. That really happens. So you get as it turns into more and more of a commodity, you'll get more and more phones that are vulnerable coming out because they'll be the cheap products. Then you get the protocol stack houses. One of the ways that works when you get a new protocol rolling through the industry is you'll find there'll be some bunch of guys in a corner somewhere who know how to build SIP or RTP or secure RTP, or they've figured out how to reverse engineer Cisco's voice protocol, and they have a piece of software that runs on Windows XP that makes a soft phone, something like that. So those days, those folks used to be called stack houses, protocol stack houses. They'll sell a protocol stack to a vendor, like they'll sell it to a Korean mobile phone vendor who's adding voice over IP, that kind of thing. This is cool because you can, as a company trying to build a product, you don't actually have to hire engineers. You just find somebody who's already got it and you write a check. That's cool that way. It's not cool from the point of view if you get no genetic diversity. And we have seen issues with this. The SNMP vulnerabilities that sort of ripped through the internet about 5 years ago were partially because SNMP research was the primary vendor of SNMP implementations, and they had the same code in lots and lots of vendors' products, and therefore they had the same vulnerabilities in lots and lots of vendors' products. So you really should pay some kid in the back room to build this protocol with their bare hands in some cases, because otherwise you're going to be just as bad as your competitors in terms of security issues. All right. Vendor priorities. Now, this is obvious to some of us, but I need to remind you of this because I'm thinking about why you would look at where would you look for potential vulnerabilities. So, they're going to think about stockholder value. It's like, notice customers are like, I have to get down to number 6 before I put customers in. So there's stockholder value, which means they want to sell stuff. It doesn't actually have to work; they just have to sell it. And then there's the image, because it has to look cool. So we have to have Cisco phones getting product placement on Eureka. Watch that TV show? It's like, you ever notice that all the executives have Cisco voice phones? So they're doing product placement things. So we don't have to build real code. We can actually get our products placed in scenes in Hollywood, and so it must be cool. Market share is important, so you want to have your product out everywhere. Your market position, whether come up with some statistic to cook to say you've got more of something than somebody else. And then you get the optional things, like maybe it'd be nice if the product was stable. It doesn't really have to be. It has to get through the sales process. I mean, the demo has to not blow up, and you have to a thing has to stay alive long enough so the check clears from the customer. But after that, I'm not clear if you need anything after that. Customer satisfaction is optional. They're thinking about the suit they're selling the phone systems to. They don't care about the geek who had to keep it alive. So that's way down there. And security is very optional. Nobody would care about security. Nobody really cares about this stuff. It would be okay if the entire phone system died, right? So that's way down the list. And so if you're trying to think about where to look for weaknesses in people's products, you got to remember this sort of priority kind of thing here. So a sexy phone that had, a voice over IP phone that had Dolby 5.1 surround sound and looked really cool if you were running it on the command center and on Stargate Atlantis when they were dialing the gate and they could push a button and it related to the gate dialing protocol. That would be so worth putting that feature in there. And I don't care if it does clear text telnet sending JavaScript that's unauthenticated with local control. It would be fine. That would be an acceptable product plan. So you gotta, who knows what they're going to think like. Stupid vendor tricks. Vendors do some dumb things that they don't realize that look like this from the outside, because developers don't stand up here and talk to other people. They hide in the back room and drink Jolt Cola and write code and whatever. And so there's some disconnects that are astounding that you see in big and small companies. They'll tend to put things on a resource-poor platform. They'll make comments like, I can put Dolby 5.1 surround sound in, and I can add 506 different chips in there to do enough crypto to the digital rights management so that I can ship iTunes because I signed a license with Apple. But God forbid I could digitally sign anything in the protocols. They'll say, oh, I can't do that because we have no resources. Well, they do have the chips. They just don't spend the money in the right place. They'll do partial protocol implementations. You keep going until it works good enough, and then you stop. You don't actually build the whole protocol. They don't do testing. This is sort of, some vendors seem to have sort of developed this habit over sort of the past 10 years that it's okay to not test things very much. Just sort of ship them out there. The customers will test them during beta test. The Microsoft example, not that Microsoft did anything wrong with this, but you look at some of the numbers. That NT's beta run was 70,000 users or something like that. So they had 70,000 idiots out there doing free QA. It wasn't really free QA, but that's a net result of these long beta programs that people have. So you end up with free testing coming out of the customers. So why pay for QA if you can get the customers to do it for free after they've sent you a check? They don't seem to have security requirements. The idea that I might attack the phone didn't seem to occur to these people. And a lot of these products are getting designed certainly after the industry started to become security literate. So, the Cisco phone that was designed in 1998, maybe it's okay that had few security features. Any Cisco phone that's shipped in the past 2 years and is supposedly fresh product and fresh code, what's your excuse? What, you think nobody's been doing bad things on the internet in the past 2 years? You get that kind of an effect. They want to do feature creep. So, this week I've got a phone. Next week I want a phone with a display. Then I want a display with a web server in it. Then I want to download images. Then I want a sound. Then I want to play music. Then it's got to play iTunes. Then I have to do camera phones. And just keep going and going, adding features into these things. And every time they add more features, you get more integration points where they can potentially have flaws. They don't seem to understand modern networks, the phone telco types. Doing this product review thing I did, I talked to Avaya, and I'm trying to configure their box, and I said, so where do I plug in the syslog server? It's a machine, it's on the net, I'm supposed to look at the IP packets, it's a server. So I asked how to plug in syslog. I thought that was a fair question. What do you do for logging? And their response was, what logging? I said, well, what do you do if you have, customers have an issue and they want to see if there was a glitch in the product? And their response was, oh, there's an analog port in the back, and the thing can phone home and have the repair guy come out. It's like, we don't need logging. Who would need logging of things? Now that's getting a little better now because you get things like regulatory requirements, which say you have to be able to see the logs and show the auditors. So it's getting a little better. I'm finding that you should do that. It'll make it more secure. Nobody pays attention to me. If I say, if you don't do that, you may fail the audit, and the CIO gets to explain it to the boss, that gets money sometimes. You might fail the audit is apparently a good pickup line to get people to spend money on security. It helps if you can prove it, but that's still, it gets them thinking. It actually gets them thinking. So they don't think about security or role-based management or auditability or any of these things we're trying to do in the rest of the networking world to trying to make things better. And then they do proprietary protocols. Now, we keep going through this. If people build a proprietary protocol, 6 guys in the back room, or maybe 1 guy in the back room, designs this thing, cooks it up, thinks it up, prototypes it, ships the code to all the rest of the developers. They put this thing in the product. They assume, they show QA all the cool features, and nobody ever actually bothers to fuzz it or check it for validity or see if there's any edge cases or that kind of thing. And then it gets deployed to the field, and then some high school student in Germany who's bored sits around, writes a 4-line Perl script that fuzzes something and things fall over. We've had this happen over and over again. Maybe without the, maybe the Perl script's longer than 4 lines, but not necessarily. And so basically, if there's a proprietary protocol in your product, it's flawed. Just day one, it's flawed because somebody's going to find something someday. Because that's why we have peer review and standards, protocols, processes, and all that kind of stuff. Because this is a bad idea. And the computer business learned this a long time ago, but the vendors keep doing that because that's the cool way to, do the shareholder value kind of thing. And security being optional, we don't care about that. So if it's got proprietary protocols, somebody's going to screw up something at some point. And also, by the way, they'll have no documentation, or it'll barely be documented. You find scary things like, I bet aren't decent standards on the Cisco SECP protocol inside Cisco. I bet there's no decent protocol spec written down on the inside. You'll find embarrassing things like that. You're supposed to read the source, or use the implementation that was already there, or something. So it'll be hard to bring in new people to work on it, and it'll be easy for new people to do screw ups. So you get this bad cycle of they do a proprietary protocol. The 5 guys who built it build the first version, it works fine. Then they outsource all the code to Dashistan and give them the protocol spec, which wasn't really very well written down, and tell them to build a new copy on the new phone, and they do what they think is the right thing, and they put a hole in the thing because you've got this extra process there. And since it's a proprietary protocol, you can't buy validation suites on the street. You can't hire extra people who know the protocol to look at it. You can't find people who've been building that protocol for years to help you find the bugs in it. It's like I got paid to fix a ping of death bug in '94. I'm trying to look up the notes when we were doing the Cisco ping testing. I think '93, '94. And I'm sitting there in my lab trying to build my course and go, oh, gee, I suppose we should try different ping sizes just for the hell of it. And we start to find things. Me pulling 10-year-old, 13-year-old vulnerabilities out of my hat to try on modern phones, that's embarrassing. That shouldn't work. It should be we shouldn't be there. People who don't look at history are doomed to repeat it. It's one of these things. So, delivery flaws. So there's things that vendors do to deliver stuff which is just broken when they ship it to you because of what they're doing. And it's about the vendor and their attitude and their processes and what they're spending money on. And it's actually not got to do with the code. And it's also probably not got to do with the coders. So I'm not saying people who code things are stupid. I'm saying the managers who pay them and direct them may or may not have reasonable marching orders and stuff. Software development lifecycle deficiencies. How do you should be able to have, if they're really doing software development in the modern style, there should be a lifecycle process, and they should have specs and requirements documents and test plans and all that stuff they teach you in school that people do when they develop software. Lots of vendors don't really follow any of these processes, and you can find things where there are deficiencies. You can see that as an outsider when you start looking at products. If they ship you a product with spelling errors in the text messages coming out of it, that's a signal. If you see, if you go read the release notice, you can discover that the QoS implementation in the phone you're looking at has been revved 4 times in the last 3 weeks because they keep getting it wrong. Then obviously that code's brittle and unstable. So you can see things by looking at the deficiencies in the software development lifecycle as an attacker on the outside. So they're generating signal by screwing up. They tend not to be security literate. They don't assume they have to worry about this stuff until after the fact, if at all. It's like, oh, we didn't think about security when we built that. It's like, well, why would you not think about security when you built some mission-critical infrastructure component like the phone system? Testing deficiencies, they won't do enough QA. They won't do the right kinds of QA. They won't do QA, which tests for negative things. They won't do edge case testing, stuff like that. You can tell this is going on because when people sell things like the Muse security hardware fuzzer, that's essentially what it is. It will send lots of different kinds of packets at a target to see if it's got flaws. Those things sell. Well, if all the vendors already had this working, they wouldn't need products like that. So you can tell that there's deficiencies, and they're trying to do things better because they weren't doing them at all before. You get vendors who will ship things that they say, well, put a firewall in front of that. Cisco routers, if you plug in the FXI, FXO card, which is the thing that has the analog phone interface on it, if you plug one of those in and you turn on the machine and you enable the interface, it turns on H323, which is the protocol that you use to talk to that thing. Well, that's fine, but it turns H323 on with no authentication at all, which means if you take your random Windows box running NetMeeting, because Windows XP ships with NetMeeting, and you say the H323 server is at this address, you can start talking to the router directly. So, there's no authentication that wouldn't stop you from doing that. And then you could make phone calls that nobody could trace. So we found this, we reported it. Their answer was, oh, well, that's just the way it is. You were supposed to do enough switch ACLs in between that you'd stop it. So this is like, don't ask, don't tell, don't attack, kind of thing. It's like, it's okay, I can ship an insecure product because you could put enough layers of stuff in front of it so it would be okay. So I'm calling those prophylactic solutions. And that is a technical term, not a rude comment. But anyway, put a firewall in front of my product because it's too weak. People think that's a reasonable thing to say when they sell products. That's just silly, in my opinion. Vendors, they want to do network access control. So, because endpoint security is hot. Addison Wesley paid my buddy Mark to write this book, and people care about endpoint security. And you pick up the newspapers that are cover these things, and they're all talking about network access control and network NAC and NAP and all these other. It starts with N and it's a 3-letter buzzword. That's all fine and good, except then you discover they normally meant network access control means control of my Windows desktops, which is nice. Windows desktops should be running the right antivirus software and all that crap. I agree. But what about the printers and the phones and the access points and all the other IP addressable widgets you have on your network? The monitoring cameras that you put up outside every door that had a proximity card on it because you went to the talk the other day. All that stuff is on your network. And so they want to do network access control and control everything and know every user, and yet you can't assume anymore that it's a computer with a human next to it and you can identify the username. What's the username for the phone outside the door to the garage that you can pick up to call in? There's no user there. So they're schizophrenic about whether NAC is in this picture or not, and they act like everything has network access control and it's all, the world is now safe. Well, the world isn't now safe. The world is now safe if you have a really simple network. They cheat on the non-voice protocols, the protocol stacks, all that stuff. They do immature implementations of the voice protocols that are there because they're trying to rush products to market. So it's standard kind of vendor flaws that happen. He's added another light. Obviously, the questioning is going to increase here. Then they have flawed proprietary protocols. So they keep doing these kinds of habits, and you can watch the habits happen, and then if they're doing that kind of stuff, you can use that to identify if there's going to be flaws in their product. If you're trying to look for vulnerabilities here. All right. So anyway, just sort of vendors are stupid, and it takes a lot of vendors to change a light bulb, and there's going to be flaws in the stuff. Just assume that. So anyway, that's kind of the attitude going into this. And yes, that's negative and snarky and all that, and unfortunately true more than it should be. All right, predictions. Let me just back up another one thing. If you're going to write a 0-day about because something you saw because you're seeing this, don't put my name in the comments of the code. Just have a good time, whatever. Use some responsible disclosure procedure. Enjoy yourself, whatever. And yeah, I might predict something. I'm not like right all the time, but every once in a while I actually do get things right. So anyway, some predictions, and the idea here is think about things I'm predicting if you're trying to go chasing vulnerabilities. So you're trying to if you're trying to go hunting for things. First thing is the legacy telco stuff. So before the internet, before the .com internet boom thing, we had these telephone networks that were very fancy. They had ISDN and a bunch of other actually fairly sophisticated protocols built in. But they were all totally closed systems, and so they were often completely unsecured. They had no passwords, or they ran telnet, or all those other kinds of ugly things that people used to do in the bad old days. So they're possibly completely unsecured targets. And if you're talking about a modern infrastructure, the box that did the old-fashioned telco stuff may just be across the aisle from the brand new box that does voice over IP, which means you may have some internet-accessible thing sitting across the aisle, connecting to this old kind of gear. And so you may be allowing remote accessibility, and these old protocols people don't understand because, basically, if it was before the iPod, it can't be high tech, right? That's sort of the boundary now. If you think you're an old timer because you remember Windows 98, you're really old now. And God forbid you remember DOS or BBSs, dial-up BBSs. That seems to be the generic old-timer comment at HackerCons. Dial-up BBSs. I was around in the late 80s or something. So, well, some of us are writing code in the mid-70s, so don't try that. I can do the old geek thing to you all. So anyway, you get this old legacy stuff, and it could potentially be connected in, and they assume nobody would ever find any details. Now, can you see? Oh, you can see this. Good. I can't move. Let's see. No, I can move the pointer. Okay. If you look down here, we have a username, wap@singular.com. This is from the help screen for AT&T's setup if you have a Motorola V3 Razr. This is from their website. I got this image, okay? And that's the URL. You feel free to go there. So it says, notice down here, I get the mouse to do its thing again here. So there's a username, wap@singular.com, and a password, a hard-coded password listed on the website. And then it's describing that it's ISDN. Mouse, 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 there we go. So it's an ISDN line. So I'm sure they think ISDN is some Greek term that nobody remembers, and some of us remember these protocols. And what happens if they're doing stuff like this today? What happens if they have this kind of a box tied into a voice over IP network, and somebody figures out they can jump across some gap and telnet into something with that username and password and start setting the ISDN parameters inside the switch? They're assuming, I'm sure they assume that nobody on the internet today can spell ISDN or remembers any of these things. So they just think this is some, character string you're supposed to type in when you're, configuring your mother's phone because you bought her a new, you bought one of those, pink razors on, eBay and you gave it to your girlfriend. And so then you program the phone so she can go use the browser, that kind of stuff. Your boyfriend or whatever. So if they're doing things like this now, then, why should they assume these people are going to build a secure network tomorrow? And by the way, after you finish going through this agony to program your Motorola V3 Razr on the Singular network, when you get to the section where it says, how do you do email, it says, put in the host name. And it will send on port 25 to that host. Anybody. So all Singular internet literate phones are capable of talking to port 25 anywhere. They don't block that going out. So if you want to build a really good spam zombie network, take the phones. Yeah, and I've given this, the passwords up there on the website talk about a year's worth. Yeah.
If you call and ask them, they'll tell you. It's free info. It's on every phone.
Yeah, and if you change your service plan for Singular, they seem to sometimes kind of reset your password on your voicemail also. So they have other problems. But they're part of AT&T now, so we're all safe. Yeah, the new AT&T, the new insecure AT&T. So anyway, features, areas that are going to be problems. So there's all kinds of new platforms coming out. You've got Windows platforms. So, it's Windows, and I don't care, it's Windows. The thing that's interesting is if you talk to somebody who does work in the kind of embedded space using Windows, and there are various, Microsoft seems to keep evolving the products, and I can't keep track of what they currently are. I've heard Windows CE, Windows Mobile, Windows XP embedded, various and sundry names of things which are in some way, shape, or form Windows on some platform. And so Windows Mobile happens to be one of the instances of it now. And if you start talking to developers who live in this space, you ask some of the sort of the simple questions like, is there a Windows update? And sometimes you get the answer is no, they don't even have a mechanism to ship us updates, never mind us putting them in the phone, into the platforms, the target platforms. So you end up with questions of, okay, so you pick this operating system, fine. What if somebody finds an exploit in some DLL? How do I get the DLLs out onto all the phones? How do I do update to my phones? So this is kind of, and if it's in fact the same platform, you can start to think about potentially the same kinds of exploits working. And again, there's lots of operating systems here. I'm not just picking on Microsoft or anything. So you get, is there a kind of an update mechanism? And think about, what would we do what would they do if we had a 0-day against BlackBerries? While we tell the people at RIM to refresh the network and update all the phones. Well, they seem to not be able to do that these days. They crashed the American network 2 weeks ago, and they crashed the European network last week. And I'm sure the people in Japan are totally freaked because they're going to do that update there next, right? And I'm sure they'll say we have it all worked out now, right until Japan goes offline for 6 hours. And yeah, the poor people at RIM, I'm sure they're not happy they're doing that. And I'm sorry to bash on them, but it happens. So that is the sort of example of, because the simple thing is, if there's a flaw and the vendor knows about it, and you guys, whoever did responsible disclosure, and then they build the update, then you got to ship the update out. And that gets more and more complicated with small devices. iPods, if iPods turn into phones, then we'll have all sorts of interesting things. You got multimedia stuff going into your phone now. So this is the company that shipped QuickTime with JavaScript with local capability until somebody caught them and then they patched it. So that's one of those, somebody caught,
At least they have the ability of patching.
Yes, they have ability, well, we can talk about that. Yes, you can patch QuickTime. I reloaded QuickTime. This laptop, I had actually built this up during the week, which is why I thought of putting that background slide up there. If you load QuickTime, it's really hard to tell them that you didn't want iTunes also. So their update mechanism is a little odd. It's got. Yeah, you have to keep unchecking the box. They keep trying to give you iTunes. And this is what I kind of try to politely call the Burning Man protocol strategy, which is sort of the Apple strategy of some naked girl at Burning Man who's just standing there asking everybody to come up and kiss her, kind of thing about the protocol. So you switch on the wireless network here and you can recognize the apples because they're sitting there screaming to do a reverse DNS lookup with your username and your host name and your IP address and what version of OS 10 you're running, and presumably it's going to tell me where you bought gas last time if I bothered to look at the right packet. But this whole I want to be sharing things, and it's designed to be an Apple, and it's free and cool, and the ads have the cute guy in it as opposed to the dweeb in the suit. So that that style of protocol, it's the style thing, means that they're going to build protocols into their products that are likely to do that sort of thing. And if that assumes there's no malicious people watching.
But the difference is that, for instance, the iPod, if it turned into, once the iPhone comes out and there is some vulnerability, tomorrow they could turn around and push an update. The next time you synchronize your phone, that update.
Yes, if they could push updates to the phone.
Right.
There's some.
With Windows mobile devices, there's no way unless you.
It's not the vendors. The operators and the FCC won't let you update phones that fast. So, assuming Microsoft were perfect and Apple were perfect and Cisco were perfect and all these companies were perfect, you still have issues about getting updates into phones.
Apple has the mechanism there.
It has a mechanism, and it works sometimes.
But Microsoft does not.
Well, in mobile, I haven't tried Windows Mobile. The last time I looked, it was XP embedded.
Do a firmware update.
If you can, yeah, okay. And that's what it is now, and the phones are still a moving target, so who knows what phones are going to have in a year. Life cycle of a phone is about 3 months. They pull up new devices. The Motorola V3 Razr came out, and it was the cool, hip thing to be carrying in your pocket when you went to a nightclub because it was a nice, thin phone. And then they came out with the V3R and the V3S, and it turns out that they just keep throwing implementations over the wall, and so they don't pay attention to the issues they have in them because they're commodity devices. They're like fruit. They go stale. You just dump them and do another one. Then you get the embedded products, which are something else, some other operating system or some custom thing. And generally, those are going to be, especially once we get into things being more and more commoditized, they're going to be as under-engineered as you can get away with doing it. So they'll do as little as possible to ship the product. And so that's going to be another example of a place where people will do shortcuts. And they'll assume nobody would ever reverse engineer things. Nobody would ever figure out how WiGAN protocol works behind smart card, behind proximity cards, and nobody would ever figure out how to look at the inside of iOS to figure out what the decompression format is. And so there's a whole bunch of this. Oh, it's a embedded system. Nobody could find out what's in it. Well, I don't think that's a good attitude. Next level up, protocol stacks. Don't assume the vendor can spell IP. I don't care who they are. Don't assume the vendor can spell IP. They seem to get these things wrong frequently. And all the protocols, they keep doing fresh versions of things, and so they're fresh and they're vulnerable because it's basically the 1.0 implementation all the time. And then you get the voice-specific things, so they're trying to do fast-moving changes to protocols and try to implement products with them, and so they're going to have stability issues. And they're trying to rush things to market to, like these days, everybody wants to have a phone that looks as cool as possible before iPhones really ship, because they're going to have to compete with that. And they're going to, people are going to suddenly want to do music on their phones and whatever other features you can do in your iPhone. So you get these arms races back and forth, and they'll keep shipping things fast, which means you'll get vulnerable things being shipped, vulnerable protocols, because you'll end up with all the vendors trying to chase the same thing. So they'll want to do cameras, or they'll want to do Dolby 5.1 surround sound, or something silly like that. Or they'll all want to plug into a BMW, so you can have your phone sitting in the docking station in your car, playing music, while you're on speakerphone, downloading PowerPoint from your enterprise. So yeah, well, that's why you do this in your car, because you said you need extra batteries. It'll suck power to do this. You could build attacks that suck power out of the batteries. Running a no-op loop will cost power, so maybe that's a good enough exploit. Then you get these things called convergence phones. They have voice over IP and a TCP/IP stack, and it's a GSM phone or whatever phone on the other side. So you get those things. Think you're going to, the fantasy picture like Nokia describes it is, you pick up your phone on your desk, you're talking on the phone, you're on 802.11 with 802.1x, and it's all authenticated and cool and hip and secure. And you walk out the front door of your office, you walk down the street far enough, you lose signal from your office. You connect to the carrier's wireless, GSM network. It re-authenticates magically somehow. You walk down the street. You walk into the Starbucks. You jump off the GSM network onto the T-Mobile wireless network. Re-authenticate yet again. And all the time you're still in the same, conference call you were listening to. So this all sounds wonderful as a feature capability. However, you get things like you just handed that off across 3 different authentication systems, which you have to have wired together intimately. Huh? Blindly, yes. You have to trust them. So yeah, you have to trust T-Mobile to get their phone thing right inside their wireless, their authentication thing right inside their wireless. Then you get the fact these are dual stack platforms. So you get 2 protocol stacks wedged in a small device by people with too little budget being rushed to do it too fast. So this is a good way to take a bunch of really smart people and have them build really buggy code. That's sort of the general effect you'd get out of that. And then you get all these edge cases due to handoff of protocols. So you're changing networks, and you acquire an address on a new network. You got DHCP lease changes underneath other connections and stuff like that. And protocol edge cases are the kinds of things that vendors tend to test for badly and attackers tend to test for well. Because you can sit around in your house drinking Jolt Cola, writing Python scripts that generate bizarre connect messages, and they all should be handled if everything was done properly. But that's the kind of goofy stuff that people will get wrong. And then these are new paths to attack other things. So you can get into an enterprise from the GSM network now, or from T-Mobile, if you actually can do this convergence walk back and forth thing. If people do enough things badly about how they integrate these systems together, you can attack businesses through the phone system now, not just by trying to go through their firewall. And you get new paths into sort of resource sharing kinds of environments. So you get things where you plug your phone into the docking station at home, and it's also your iPod. So of course you want to have it hooked up so you can play your iTunes music on your high-end stereo at home, or connect it to your TiVo or something like that. So now all those boxes are on the same network, wired together, running who knows what protocols back and forth, and potentially having attacks go back and forth. So you can attack your stereo. Maybe somebody could build an attack that goes into your stereo and deletes all that music you bought off of iTunes. Did you know if you sign up for iTunes with PayPal that it pre-authorizes a $5,000 charge in your PayPal account? Wouldn't that be a nice place to deploy a virus? Anyway, did I say that? You could attack your BMW. I don't know about BMWs, but I know that Daimler Chrysler products have gear in them so you can plug your iPod in and it connects in. So, Is Windows CEO. That makes me feel really safe being cut off by a Z4 next time as I drive back up I-5 to go home.
Thailand, where one of the ministers was driving a beta prototype and it locked up on the freeway. The engine stopped.
So there have been failures. So there have been failures of cars with software failures of cars. Yeah, right. And this is mobile devices are going to be involved in all of this, and so these are attack vectors. If you're trying to think like a bad guy, what would you try to do what could I do with a phone exploit? Well, if I can start to attack your car, that sounds cool. Or you can attack if you download a bootleg movie that you got off of BitTorrent, because you thought you were cool, and it's got some sort of bizarre active content in the movie, and then you stuff it in your DVD player, and then the exploit walks through the home network into your phone, and then you take your phone and go to work, and then it can climb into your employer's network. That sounds like a bad Tom Clancy novel proposal, but that's a target that could happen. Somebody could do something silly like that, and depending on what kind of environment's out there, that's got all the right conditions for somebody to go out and develop something like that. Somebody pissed at the RIAA who's trying to do bootleg movies, who's trying to exploit other people who were downloading that kind of stuff. So you make the bootleg movie be some exotic girl doing yoga kind of thing. So everybody will download a copy. We can't do Paris Hilton anymore because you can't make any more movies from jail, we assume, right? So you'll have to have some other kind of bootleg movie everybody has a copy of. Yeah, behind bars. Yeah, Paris Behind Bars, the next movie. Yes, anyway. Anyway, crypto. So I do crypto stuff a lot. Voice vendors don't understand crypto. First of all, they always say the hardware can't handle it. They say, it's crypto is hard because you have to do lots of CPU cycles and we'd have to have special chips and things like that. These are the same people who have SIM cards that are doing RSA encryption already. So the hardware can handle it. It's just an excuse. People will do things like have authorization systems that you log in to do something, and your login never times out. So if it's your desktop computer and you log into your Gmail account and never times out, well, yeah, fine, whatever. But if you've logged into something on your mobile phone, on your phone with voice over IP, that's your convergence phone, and then you leave the phone on the subway, and the authentication tokens are still sitting on the phone or in the cookies or whatever, the JSession ID is still there or whatever it is, and that's immortal, then somebody can pick up the phone, clone the data out of it, and authenticate as you. So that's a crypto problem, and it's not like the algorithm's broken. It's that people are misusing the stuff. All the regular rules about crypto. Don't use proprietary protocols. Don't make up your own crypto algorithm. Don't roll your own implementation with your bare hands unless you really know what you're doing. Make sure you do some things to check it to make sure that it does actually work properly. All that kind of stuff about crypto. And these being small devices and new implementations, we're always getting sort of people showing up going, we can do our own special implementation because we're cool and different. We know this is okay to be doing this. It's a closed environment. We'll get away with it. Nobody would ever look at our encryption algorithm. So anyway, people are doing things like that. And the crypto should work. The RSA stuff should check the signatures. If you have a web browser doing money kinds of things through your phone or through your, or your voice phone has a big fancy display to show customer IDs and stuff, you should actually do all the proper crypto stuff. And people forget this. There have been phones shipped that didn't check the SSL signatures. There have been phones shipped that had bad roots in them or don't let you load new roots. That's another thing about the phones being different. Look at the roots loaded into a BlackBerry, and look at the roots loaded into a Windows mobile device, and look at the roots loaded into a Motorola Razr, and you'll find different things. This is the world where you can walk into a Singular store and hear some customer at the next counter yelling at the person behind the counter because they're getting a root certificate not loaded error. Actually heard that in a Singular store. Now, I get those errors all the time because I do crypto things, but end users hitting root errors? Anyway. So this is and people want to use the phone for other things. So the voice over IP stuff is going to be sitting there with browsers trying to do other kinds of authentication and stuff. These devices have to have keys stored in them somehow. So you need to make sure the keys are stored safely and securely, and you can't read the things out, that kind of stuff. Let's see, how am I doing on? I'm 10 minutes over, right? Yeah. There's no hook thing in the back room. You're not waving at me. Of course, you may be, but I can't see you in the dark. Anyway, I'll go speed up. Data formats. People getting implementations wrong. Again, stuff like that. Targets. Cool targets. Rich media things. Multimedia stuff, QuickTime in your phones, being able to send voicemail messages or animated voicemail or something to your voice phones, or having your systems tied together. Aggressive, active content. JavaScript's not supposed to be doing things. Attacking the phone stuff itself. What if we had weird signals coming in and attacking the codecs? So that's the coder decoder. It's taking the audio signal or generating the audio from the binary, from the digital data. We can have attacks against that. People are putting games on phones, so they'll start putting games and things like games on voice phones eventually. Web 2.0 fad services. Dodgeball. Anybody use Dodgeball here? It's like everybody was using that at TourCon last year, and I'm thinking, so all the hackers in one city are trackable by one service run by Google. And you're going to I'm going to send you an SMS, and then we're going to go to the ATM, and I'm going to get the $300 I'm going to pay you for the 0 day that you gave me. And they're not going to be able to track that when we're all running Dodgeball. Anyway, so you get these Web 2.0 services which assume you want to share a lot. And sharing a lot usually means not very secure. Anyway. Enterprises. You can attack enterprises with VoIP phones. It's another target, another attack path. This is a bad thing. They're all running Exchange, Microsoft Exchange, which it's not like Exchange is a bad thing, but it's a sophisticated system, and you've now added a new path into it. So you get new cruft potentially coming into your email infrastructure. Plus you get things like the Cisco Unity Server, I think is the product name, which is essentially an old copy of Exchange running on Windows 2000 that Cisco refuses to let you update. So this is a classic case of, assuming Exchange is perfect and Microsoft ships me perfect maintenance releases, I still can't use it because the way Cisco did things. So you get funny combinations because you've got sophisticated email systems. Voicemail and email going back and forth. Blended attacks. What if we have spam causing you to hit a phishing site, which causes you to download something which would attack your voice phone? What if we had that combination? People put fancy things in their phones, and now you've got more data there, so it's a better target. So you get the sales guy who has the fancy BlackBerry whatever phone, and they download a copy of the business plan onto the phone, and then they're running around doing things, and they've got a voice over IP client, so they can also do Vonage or Skype or something like that. And now you've got all the conditions where you've got an interesting piece of data on a vulnerable target that you know how to attack. So you can have reasons to go after phones, even better. And then, of course, there's all the traffic, because I can see if I can identify your voice traffic, I can see your motions and where you're going and what you're logging into and stuff like that. Anyway, voice people when they deploy these infrastructure things, they tend to take the network types and make them play with phones, or take the phone types and make them play with networks. So you end up with competency gaps because they don't overlap. People who used to do phone stuff tend not to have been like iOS wizards. And people who do iOS, if you have a CCNA or a CCIE or whatever you got, you probably don't know every single command in your Nortel phone switch. So the same thing both directions. So you get combinations that are issues. And you get, again, places you can look for exploits. People will use old copies of iOS because they think if it was part of the phone system, we're going to leave it alone for 10 years. So do you want to be running 10-year-old copies of iOS? That Cisco wouldn't say that was a good idea. But people might think about that because that's the way they look at their phone system. So you can get attacks that way. People will run really old gear. We don't catch people running Windows 2000 servers mostly these days. The vendor tells us not to. There's lots of reasons not to, whatever. But there are people in voice environments using things of that age or older. So anyway, making things better, just quickly. The real thing, the way to make things better is if we can convince people to stop buying stuff that's not secure. So the real kind of exploit that's really valuable is, if I get a phone call from some sales VP at Nortel that says somebody screwed up a sale because the customer bothered to ask questions about security and they bothered to run Nmap on the phones or something. So that's the way to make it better, is to make the sales be impacted by the security problems. Dropping ODate and scaring the hell out of people is lots of fun, but if we can actually get the sales process to be impacted by this, this would be the way to actually change this kind of stuff. And potentially nasty things. We talk about the lawyers going after us, evil hackers who are looking at things. Why aren't the customers suing the vendors when they ship screwed up stuff? Why aren't there class action lawsuits? If you could lose your business if you had no phones for 24 hours. Lots of people, their businesses can say that, which means that's a target. Which means if that happened because the vendor shipped insecure product that they were negligent about, that's a potential lawsuit. So, that's the other way to get this to work better is, sue people when they ship you insecure stuff. I know that suggests being litigious, but if they're going to use the lawyers to hit us, we should use the lawyers to hit them. And run a real network, connect your phones to a decent network. Anyway, it's kind of obvious, but whatever. Vendors should not forget it's an IP node. They seem to not think about that. Think about the security requirements. Send people to conferences who care about looking at security. Anyway, test the products. Please test the products. Don't ship things that aren't tested. They look like they're not tested. I'm sure they do some testing of some sort, but they look like they're not tested. And you should be able to do security update paths. I can buy PatchLink and I'll buy SUS. Is that the right term for the update server, the corporate kind of update server for Windows Update? Things like that. Well, yeah, except that there's no such thing as Windows Update for Cisco 7940 phones. There's no easy way to, I can't go to my customer and say, get whatever Microsoft told you, run the update mechanism, follow their advice faithfully, just do what they say, and you'll be way better. That's true, right? So I can't say, go to Cisco and keep bashing on the Windows Update button on your Cisco phone until it says it's completely up to date. You can't do that. They aren't even building mechanisms to do this sort of thing. And don't go into denial about outside security research. Vendors keep doing this, like, oh, there isn't anything wrong with our phones. You guys are all just making mistakes. So there's been lots of that happening. Presumably that's the level before they start suing people.
Is that update non-update due to planned obsolescence? Are they trying to force products to be planned?
They have no concept that you'd want to maintain your phones. I don't think it's planned obsolescence. I think that they assume that you're going to keep the phone for 10 years and keep it the way it was, because I think that's the way the people kept writing the requirements. And that sounds fine, but eventually we're going to end up with a phone which is in fact Windows XP. Inside a thing that happens to be very small and look like a phone, or something like Windows XP. And in which case, it's a modern operating system with modern sophisticated features and modern maintenance requirements, and so you should do the modern thing to update from the modern vendor. And that's all assuming that all the vendors doing the right things, because software has bugs and you have to maintain it. It's the way it works. You can't, 10-year-old code you cannot assume that's going to be good forever, and that's kind of what the attitude they used to have. So anyway, let's see. Vendors dump phones on the newbie developers. I think that the phones tend to be the low-end thing, and so you tend to put the new kid on it. It looks like that based on some of the bugs. Spend some money on testing. Implement full protocols. Don't give priority to look and feel over secure. Look and feel is cute. Stable and secure would be nice also. If I can make your phones unstable, I can scare people very much. So if I can ruin the stability, that's an interesting thing to do. Anyway, all right. Yeah, security research. Anyway, phones are brittle. Basically, phones are brittle. Anyway, that's it. Sorry it took too long. Thank you. Yes, I can't see you. I'm sorry because the lights are like. Over here, question, yes.
Obviously, Mac is very, it's still in its infant stage across the industry. And essentially, it has a good thought to be able to do that on lots of different active devices on your network. And your comments about the fact that it can check your antivirus on the Windows and all of that, same problems. Have you found a solution or a thought process on dealing with that?
Yeah, if you're going to do access control in your switch, make it voice literate. Do enough things so you can put some security capabilities in that, and don't just assume you can have this massively active thing like 802.1, like an 802.1x client to do that. They could do more things in the switches if they wanted to.
Are there any products out there that are doing it right that will actually defend against that?
I have not found any products doing it right. I have found products that claim they can do it, and I've seen some things that have enough horsepower. Some of the things which are called secure switches, they tend to be firewall per port kind of devices. Juniper makes some stuff like that, Juniper NetScreen. Nevis Networks, Concentury, there's a few other vendors out there doing things like that, which basically do control per port. And if they did the right set of things, they could quite capably defend a phone that way. But they don't think about it. They're busy obsessing on, you run Windows on this thing, and they'll tell you what user logged in.
That would assume that you have to write more or less firewall rules.
Yes, you'd have to write firewall rules for phones.
And how do you deal with that in a dynamic environment where you just plug a phone and plug a laptop into a wall port and go?
Well, that would be the architecture bug, wouldn't it? No, I haven't found people who've dealt with that. They don't seem to actually think machines are mobile like that.
That's the way it is.
Yeah, I mean, there's roaming stuff, but that's another set of problems. And no, I don't think that they've got that solved, really. This is an example of I don't think they thought up the security requirements that users have. I should hit you with the mic.